All right, so in this example, what we want to do is try and find a piecewise smooth parameterization of this curve shown below. So the curve traces, we go from the point at 0, 0, we come over to the point at 1, 0, and then straight up to the point 1, 1, and then straight left to the point 0, 1. So one of the things we might notice right away from this is that it would probably be easiest to break this into 3 different pieces. So to break it into like a curve 1, a curve 2, and a curve 3, and try and parameterize each of those. So if we just focus on curve 1 first, to make the parameterization, this is just two-dimensional, so we're going to need an x of t and a y of t. And we can choose our t values to be whatever we want. In this one, it's probably easiest to just start at t equals 0 and go to t equals 1. And notice, along this whole curve, we basically want to trace this line here in a particular orientation. So we really want to go from 0, 0 to 1, 0. So notice the entire time the y-coordinate should just stay 0. So we might as well set y of t identically equal to 0. And then x of t, we need to just go from 0 to 1, and it just does it via a linear function. So notice if we let the value of t just range from 0 to 1 and then let x equal t, then that parameterization will give us that line segment, that directed line segment. Now for C2, again, we're going to need an x of t and a y of t, and we're going to need t values. Now what we need in this case is the t values. Because these ones left off at 1, we're going to need to start at 1. Now this one, what we need is we need to go from that bottom point, which is 1, 0, and we need to go up to the point 1, 1. So now this time, x is actually constant for this particular function, and it's constantly 1, so we could let x of t equal 1. Now what we need y to do is we need it to increase from 0 to 1, and it can increase linearly. So we could think about, well, it only needs to go 1 unit long, so maybe we'll let t go from 1 to 2. Notice, so I can't let y of t just equal t, because then it would go from 0, or it would go from 1 to 2, rather than we want it to go from 0 to 1. But notice, essentially we just need that to shift. So when t is 1, we need it to start at 0. And then when t is 2, we need it to go up to 1. So if we just take those values and subtract 1 from them, well, 1 minus 1 will start at 0, and 2 minus 1 will end at 1. So we can still essentially use a parameterization that's linear in nature, but just shift that y-coordinate. And then for C3, since our last curve left off with t equals 2, we need to pick up where we left off, and then we can decide where to go to. This one needs to go from that point 1, 1 to the point 0, 1. So this time, y is a constant. We luckily in this one just have all vertical and horizontal lines. Y just needs to stay constantly 1 the entire time, and then x is really the one that we have to figure out. Now it can vary linearly again, so we could find some sort of linear function of t. It only goes from 1 down to 0, so we go at 1 unit in length, so probably we'll just want t to go from 2 to 3. And then notice though that we want it to decrease. So really when we start at 2, we need the output to be 1, and then when t goes to 3, we need the output to drop to 0. So we probably want a decreasing function in terms of t. So that means that we might say subtract t from something. So if we start at t equals 2, we need to figure out, well, what can I subtract that from to get 1. Well, we could subtract it from 3, which then that worked perfect because then once t increases up to 3, then we'll have x of t dropping down to 0. So this is our setup of our parameterization. So then what we can do is just put it in appropriate function form. So we could say maybe call our curve r of t. And we're going to set this up like a piecewise function. So we'll have the nice big curly brace here. And let's go ahead and write our functions in linear combinations of our standard unit vectors, so I and j. So if we look at the top one, the x component is t, so we'll have ti. And then the y component is 0, so we'll have no j component. And that was for t went from 0 to 1. The next curve, curve 2, the x component is 1, so we'll have 1 times I, and then plus, we've got t minus 1 times j, and that will be for t goes from 1 to 2. And then the last one, the x component is 3 minus t, so that'll be times I, and then plus, we just have 1 times j, so just plus j, and that's for 2 less than or equal to t less than or equal to 3. So this would be our final parameterization of our piecewise smooth curve. Notice that each of those pieces satisfy that definition of smooth. We've got continuous derivatives of our two components, and the derivatives would not be simultaneously equal to 0 ever. So this one's kind of a somewhat simple example where we're just kind of taking these strictly horizontal and vertical line segments. The next example we're going to take a look at, we'll do a slightly more complicated curve just to see what it looks like. But one thing that I want to note with this is that one of the things we had to be really careful of was that orientation. So notice that orientation of the curve is important. Right, like on curve 2, it was important that I went from 1, 0 up to 1, 1. I couldn't just represent that line segment any way that I wanted. It specifically needed to move in that direction so that in total, this little object goes in this kind of square pattern starting at 0, 0 and then taking left-hand turns at each point so that the point as it moves along this total piecewise curve is important. That would also include things like if we did have, say, like a circular curve, doing something that is in, say, a clockwise rotation would not be the same as going in a counterclockwise rotation. So these would not be the same curve, the same parametric curve, even if they are the same graphed curve. Even if they're the same circle, the orientation is important. So that's why we were careful with, say, like this second piece, y had to increase from 0 to 1 versus in this piece, x had to decrease from 1 to 0. So how we set those curves up mattered and looked a little bit different.